Could the Internet of Things someday become self-healing? I spoke to Steve Hanna, distinguished engineer at Infineon Technologies, all about this.
So to move us forward, there's a notion of self-healing of IT systems, self-healing of all this digital innovation that's taking place around us. Could you maybe frame that for us, Steve? What does that refer to?
Absolutely. So one of the things that we see with the Internet of Things is that the number of devices is increasing exponentially. That's a good thing. That's what we want with the IoT. We want to see it bridging over into mainstream adoption. And at the same time, as we see the number of devices increasing, we also see the security risks still a factor. So we're looking to build this cyber resilient devices that can detect an infection like the human immune system, and then attack that infection and get it out of the device all automatically without somebody having to be an expert in security.
Really, it's mind-boggling the scale of digital connections going on to make this happen. It's almost ridiculous to expect an individual to try and, be informed enough to keep up with that.
That's right. The number of new vulnerabilities that are discovered is overwhelming, even for an expert like myself. And to expect the average consumer to do it just isn't practical. These devices need to have built in at design time the capabilities to respond to attacks as they come in. And we can't expect that the devices will be built perfectly. As long as there are any bugs or vulnerabilities latent in the device, even if nobody knows about them, some attacker is going to find them, then that's a zero-day vulnerability they can exploit and infect your device. So we have to build in this self-healing capability that if that unfortunate circumstance happens and your device becomes infected, it can kick the bad guys out and get itself back into a good state.
This is kind of all about the software, isn't it? I mean, that's kind of the wild card here.
Yes, as they used to say, it's turtles all the way down. There is software in the cloud. There is software in the gateway. There's software in the device. There's software apps. Even inside of chips, microprocessors have microcode that they run in order to run the instruction set. So it is software all the way down. And that's great because it's so adaptable, but it's also dangerous because that software, as I mentioned earlier, always has some bugs, and some of those bugs become security vulnerabilities. So that's why we need that self-healing capability, that cyber resilience.
So how does it work, cyber resiliency?
Well, the way it works is that built into the device, you have, of course, the normal application code running on an operating system or on libraries on the metal. That's what we have today. But then in addition, you have what's called a resiliency engine. And this is a separate component designed to be protected so that it won't become infected, even if the main application code should become infected. This resiliency engine then has the ability to monitor that main code to attempt to discover if it has become infected, or if perhaps it just has a bug that sends it into an infinite loop. And if something like that does happen, it has the ability then to intervene, to reset the device, to reinstall software, perhaps a patch that's now available.
How does this relate to striving toward the fruition of the Internet of Things with smart buildings, smart homes, smart transportation?
Well, I think if we want to enable the rapid growth of the Internet of Things and its transition into our everyday life, if we want to get to that vision where all things are smart things, then we need to have this self-healing automated capability. Security just needs to be baked in. And we can't assume that devices will be coming from the factory perfectly secure. We have to assume that they're going to need some ongoing management, but we also have to understand that management can't be done by the user per se.
Could you frame that where we are now, where all that, what's ahead of us?
So when we build into a device certain things, we know that those things are going to be relatively static within the device. Set of chips on the device, well, it's baked in for life, right? And even the set of software that gets installed on the device, you might be able to update it a little bit, but you're not going to be able to make mammoth leaps in the capabilities of that software. So we build in this resilience engine with certain limited functions, such as the ability to do a reset or a firmware update, or to provision new configuration onto the device. Some limited set of capabilities. Infineon builds these into our secure chips. We're starting to build cyber resiliency into our secure chips as a capability, both to secure our chips and also to secure our customers' environments as they build their IoT devices. But the innovation, because security is always changing, new threats and new defenses, another threat, another defense. You know, it's a cat and mouse, a spy versus spy game, if you will. That innovation will happen in the cloud. That's the resilience authority. That's where they say, oh, there's a new attack that's making the rounds, just started last week. We know what it looks like. We know what the signs are.
Mm-hmm.
We are going to use the resilience engine, that primitive tool that's built into the device, fundamental tool, in order to look for the signs of that infection. And then if we find it in the device, we're going to tell it to, go back to your safe mode and install this patch, and that's going to get rid of it.
So is it a matter of approaching this from the chip level on up? And how do you get people to cooperate? How do you coordinate all the telemetry?
These are great questions. As the one of the security architects for the Matter standard for smart home, we've put a lot of effort into designing in lots of good fundamental security capabilities in Matter 1.0. I think it's fair to say that with respect to cyber resilience, this is a very new technology. It's perhaps at the same level of maturity as post-quantum cryptography, perhaps not even there yet, in that this is something that's coming out of the labs and getting installed in devices, but very few devices yet have cyber resilient capabilities. I would say with cyber resilience, we're at the pre-standardization level. Give us 4 or 5 years of trying it out and people putting it into products and learning what works and what's efficient. And then we'll be able to come back and I hope put it into a future version of Matter.
So is Matter sort of dipping the toe in the water, but it looks like, that's the kind of the path leading the way forward? And first of all, recap Matter for the audience members who might be wondering about the reference.
So Matter is a major new smart home standard. I think perhaps we could argue the biggest in at least a decade since IPv6 came out. Matter, the standard, will provide for interoperability within the smart home between devices and ecosystems from different vendors. So you can have a cloud from one vendor, a phone and set of apps from another, a gateway and devices from others, and they all should be able to work together so long as they implement the Matter standard. We aim to make things secure by default, easy to use, and fully interoperable with Matter. Cyber resilience is not something which is included with Matter 1.0. We have to get the innovation to the level where we fully understand what is the most efficient way to do it before it would be fair to drop it into a standard. So you'll see things like encryption and authentication right in there in the Matter standard and required for all those communications, but not yet cyber resilience.
So if we can get this right, what lies ahead if we can figure out security and allow the full fruition of the Internet of Things?
So I think the full fruition of the Internet of Things is a very inspiring vision. It's one in which we're able to take technological advances like artificial intelligence and apply them to some of the most fundamental problems that we have. Not just, oh, how can I optimize turning on and off the lights in my house, but also energy efficiency. Can we perhaps anticipate when a certain weather system is coming and combine that weather data with other data about the user's preference in order to optimize their personal experience and also their energy efficiency? Can we have optimized transportation, which takes humans out of the loop, increases safety, and also increases energy efficiency? And if we don't get cybersecurity right, though, none of that can happen, because people will not be comfortable riding in a car, even if the artificial intelligence is perfect, if sometimes those cars get hacked and then they go flying off the road because somebody has taken control of your car and is maliciously driving it in a dangerous fashion. We can't have that. And that's true of every domain in which the Internet of Things will be present, whether it's smart home, smart cities, smart cars, trains, buses, factories, whatever it is.
Health systems.
Absolutely. These things have to have security built in as a fundamental property, and it can't be based on the idea that humans are going to provide that security. We can't respond fast enough, and the things will just be so many that we can't go in there manually and respond and fix the problems.
Yeah, so that's why it's encouraging that this notion of cyber resiliency is even being talked about, or being talked about early, with the stakeholders all discussing how to move it forward.
Yes, I think that's right. This is a new platform for innovation. Humans will not be out of the loop. We will be very much in the loop, but in the loop as the innovators, as the ones who are coming up with new ideas. Think about it this way. The internet was a huge platform for innovation because it took things that were very hard before then. How do I get a message from one computer to another? Oh, well, this one is running this operating system and this one's running another, and they have different protocols and different, yada, yada. No, it's all IP. It's all the internet protocol. And you can just send the message from any computer to any other, and they'll both understand it. The Internet of Things has to have a similar level of interoperability so that we're not worrying about how do I send a message from here to there? How do I send it from my switch to my bulb? No, that has to be standardized. Then the more interesting stuff is, well, what can I do with that capability? What new applications can be invented on top of this? We are creating a platform for innovation that none of us will be able to predict what the innovations are that will be added. I don't know what those innovations are any more than Vint Cerf knew what was going to be invented and put on the internet when he was involved in creating it in 1969. But it's the potential for that innovation that's so exciting.
Yeah, I couldn't agree more. Thank you very much, Steve, for your time today. And it's always interesting talking to you, and look forward to our next conversation.
Likewise, Byron, it's a pleasure.